good evening, everyone, and welcome to today's session of the Leadership Lecture Series. This is Amin Naseem. I'm a fifth-year student at the Department of Humanities and Social Sciences here at IIT Madras. Today, we are thrilled to host an IIT Madras legend, Mr. Krishnan Subramanian, Micron's Corporate Vice President of NAND Technology Integration. He leads global teams pioneering NAND, breakthroughs that define peak performance. Based in Singapore, Mr. Krishnan has over 30 years of experience in semiconductor process engineering and integration. He's held senior roles in manufacturing and R&D, growing Micron's Singapore R&D team from scratch to 400 plus members over the past decade, delivering vertical NAND tech leadership. Today, he manages teams across the USA, Singapore, Japan, and Italy. He's an Institute of Electrical and Electronics Engineers senior member with multiple papers and patents. Mr. Krishnan is also a male ally in Micron's Women's Leadership Network, serving on its steering committee. He actively mentors team members and senior leaders at Micron. Many are now in executive roles across the semiconductor industry. An IIT Madras BTech Electronics and Communication 1990 alum, Mr. Krishnan earned his master's in electrical engineering from and also the master's in electrical engineering from the University of Texas at Austin, US. Outside work, he enjoys golf, Indian classical music, Indic spiritual literature, and counseling on corporate leadership as well. These are the reminders that true innovation thrives when work meets wisdom and rhythm as well. Today, Mr. Krishnan will explore the increasing importance of memory and storage in the rapidly evolving AI era, highlighting rapid advances in memory and storage, fueling the AI industry, the criticality of semiconductors to India's developmental goals, and how to build a successful career in the field, including key leadership lessons. Please join me in welcoming Mr. Krishnan Subramanian. At this time, we also kindly request Mr. Sujata ma'am to please present a small token of appreciation from our side. Thank you so much, ma'am. Thank you so much, sir. Over to you.
All right, good evening, and it's nice to be back in IIT. I've not done this. I've been wanting to do this for many years, but somehow opportunities didn't come along or timings didn't match. So it's a great opportunity. Thank you very much for the alumni office who have been communicating to have this talk happen. It's obviously a very proud moment for me to be able to come to my alma mater, and I also have a great batchmate of mine, TB Prakash, very, very, very famous innovator and entrepreneur. You can talk to him after this, and it's good to connect with him as well as be able to share a few thoughts with you. I was just sharing that it's nice to see 20 kilometers per hour driving speed coming in, where we give more importance to the deer compared to us. I think that's the right thing. Right? When we were students, I don't think we paid that much attention to the deer as much as you're all doing now. So that's a great thing. So today I'll spend maybe 30-45 minutes probably walking through an overview of where this industry is headed, and mainly the thoughts was I want to kind of debunk what we think of AI and what it is more than what we think of, and then what's the relevance to India, what's the relevance to the students who are upcoming into the engineering fields. Show of hands, how many of you are? From the faces I can probably guess 80% are students, right? Faculty, how many? Faculty, probably few. Okay, probably mostly a student-dominated session. So I can slant my message towards the students for sure. Okay. All right. So I'll have a quick video. can see the key message that you would have taken out of that is we are just getting started. This is not something, AI is not something we all achieved. We are at the very beginning of this revolution, and many of you who are going to be engineers of the future are going to be a big player in shaping this, right? And so I have broken this overall structure of this talk into about 4 parts here. Some of you are wondering what is AI cake, and some of you who have been following NVIDIA's Jensen Huang probably know what AI cake is, but if not, I'll have a picture to explain. Nothing to do with the cake, but it is a good analogy for what it is. And then what's the big data revolution that we're talking about? What's the growth of the data we are talking about? And how do you manage this data? What does the chip industry and the infrastructure do to manage this amount of data, and what are the challenges? And then opportunities, and I will talk about where is India's role in, and students' role, upcoming students. What can you do? How can you skill yourself to be ready for this transition or a lifetime, let's say, lifetime infrastructure change that's coming at us, right? So this is the AI cake, right? Certainly looks like a cake, but actually it is a message that NVIDIA's CEO Jensen Huang, he probably didn't show a picture of this cake. I created it out of the Copilot, so this is, he didn't have this picture, but he talked about, and a very strong message here is, normally when we think of AI in today's language, generally when you talk to somebody, most of the time we are thinking about models, right? If you think about it, most of the time everyone is talking about, what did Anthropic do, what did OpenAI do. Everyone is talking about models as if the model is the be all and end all. Yes, model is an important piece, but if you think about it, the foundation is, we were just chatting before this talk, foundation is energy. We need the infrastructure, we need massive power supply for data centers, then we need the chips, which is where I'm part of Micron in the memory and storage space and GPU space. How do you get that? How do you get chips, and how do you get the infrastructure, the data centers, the digital networks, right? That's the next level. Then comes building those, making these models effective. Finally comes the application. And if you look at it, application is where the value is created, right? If a company has all the LLM, but if you don't know how to use it to transform your business, you don't get any value out of it. You just talk about LLM as if it is a fancy buzzword that's nice to say in a coffee conversation, that I know Anthropic, I know this, but you have not done any transformation to the business. And those businesses that have been already operational for the last 20, 30 years, it's not easy to make that change. You can't rejigger current business into AI model. You almost have to break existing systems and recreate them for AI. But if you're starting a company new, obviously you can make it an AI native company. So it is not that easy to make the application. But really all the money is made in applications. In terms of people, the majority of the people, if you look at it, there will be a lot of people in energy, a lot of people in chips, a lot of people in infrastructure, a lot of people in applications. There will be a small number of people in the models relative to the large thing. But I say this at most talks I give because it's a misunderstanding. Everyone thinks that all the work is in models, which is not the case. Right? Models are important. Right? So I did whatever I said is essentially leadership requires infrastructure thinking, not just the algo, and you can see foundation to engine to scaling layer, intelligence. Constraints are at the bottom. And today, and I'll talk about in the end, the biggest constraint is power. So constraint is the bottom. Value is realized obviously at the top, but the work has to be done right from the bottom. Right? You can't realize the value at the top if you don't do the foundational work. So all the countries are doing, not just saying, okay, let me develop the next cool model, but trying to build this entire infrastructure. Only then you can succeed in this game. I thought this is important to what I was going to say for students in the very end, so I want to kind of add this background. Now, this is here to stay, and the amount of investment that's going, you can see it's all billions, right? Billions. Sometimes you can't even count the number of zeros that are after these billions. It's huge. Even from Micron, we just announced 4 expansions within the space of about 2 months. One in New York, one in Singapore, one in Taiwan, and then we just had an opening. Some of you may be following. We had a factory opening in Sanand in Gujarat, which Prime Minister Modi inaugurated last Saturday. So, and if you are doing it, so are all the competition, right? There's massive investment ongoing. And of course, there's a lot of talk about is a bubble. We will keep that to a maybe post-talk conversation. Is there a bubble here, or it's not a bubble? But essentially, everyone's investing because the returns are humongous, right? Now, where is this? Now, where is the data coming from? So, many of you would have seen these graphs that show the massive growth of data. before you can project the next bar chart, the data has already grown beyond that. So these are humongous numbers, zettabyte kind of numbers, and this is driving the economy. And you would be surprised to know that the amount of data that is being used today to create intelligence, right? Data has no use if you don't convert the data to intelligence and insight. The data has, it just sits there. The data that we are using today to create intelligence is less than 10%. So for the existing data, but data itself is growing at an extremely rapid pace. So there is two things. There's rapid growth of data as well as underutilization of existing data. So both put together, you can see the amount of systems that we need to utilize this data that's coming out is huge opportunity for us, right? And from the chip industry itself, we were targeting a 1 trillion chip industry by 2030. 2026 we are already hitting it. We are 4 years ahead. We are pulling in the 1 trillion for chip industry has pulled in by 4 years. So you can imagine the size of investment, size of growth of the memory storage GPU market. It is just mind-boggling. And the memory component of that is about 30%. Used to be about 10-12% of the whole. You know, we are all used to talking about Intel microprocessor or the NVIDIA GPUs, etc. But the memory, which is NAND and DRAM, used to be only about 10-12%, maybe 15%. Now it's in the range of 30 to 40%. So you know, it's the overall growth is highly dominant. It's growing faster than the rest of the market. Right? Now we already saw in the video, right? AI is everywhere, and everywhere there is AI. So those who are Advaita Vedanta minded will see the parallel to all the Advaitic philosophy that we see in AI. So data center, as you know, and we're talking about data centers springing up like mushroom everywhere all over the world, right? And then AI at the edge. I think as much as this is all the big news, this is going to be where we see the most, consumer will see the most benefit AI at the edge, whether it's on your phone, whether it's on small IoT devices, anything at home, that the maximum amount of benefit to the consumer is at the inference, right? This is all going to be at the model level, and the inference is going to be where it makes a difference to most of us. And only if it makes a difference to all of us is this business going to become big. There's no point just making a difference to data center. So the AI edge is going to be big. We're already seeing it, right? We are all using AI in our phones. We may or may not realize, but it's already doing many things for us, right? It just becomes more pervasive. And on the industrial, and this is a big piece that sometimes doesn't receive the level of attention as much as the data center, in terms of automation in a factory, medical, as we saw in the video, aerospace, video security, all the cyber security. So there's plenty of opportunity in all this because data is generated at the edge in all these areas, and we don't want the data to keep traveling all the way to data center and come back down. There's no point. You're just losing power, wasting power going back and up down. So there is plenty of opportunity, and the big one this is huge, and people don't realize how big this is. The automotive industry, which is very big in India, so it matters to a lot of us who are in this region, and China that's coming up very strong on the EV market. The amount of electronics used to be a minuscule part of the car cost. Now you're looking at 20-30% of the car cost is nothing but electronics, and in the EVs it's probably even higher, right? Electronics is all, and that's why you saw during the COVID there was a shortage of chips and there was a shortage of cars immediately. So that's a straight correlation, right? So this matters to a lot of us in everywhere in the world, certainly in India, with the automobile industry that big. So work on this piece. Now, and how do you power this? So like I said, typically we will be thinking in all these spaces, we are always thinking about the coolest microprocessors, the 2 nanometers, the 1.8 nanometers, etc. And we, in India, for the longest of time, we wanted to put in fabs that were trying to go make chips for 2 nanometers. Now we realize, that's important, but at the same time, other things are also as important in the whole infrastructure. Now, that's why the factories that are coming up are not necessarily all trying to compete in the 2 nanometer market, but there's plenty of market for 28 nanometer chips, and building the ecosystem and the capability in India is more important than trying to go for the 2 nanometer market. But essentially, we always, when we say chips, everyone thinks of that 2 nanometer that TSMC makes, the fastest transistor, fastest microprocessor, but really that's only a part of the whole thing. Memory and storage is big, as I showed in the previous slide, for the AI revolution. Now, how do I show that? As you see this on the right, the AI expansion, the y-axis is the performance. The performance need for from the GPUs going from CPU to GPUs is humongous, and the memory hasn't kept pace with that. So there is this memory wall that is coming up, where if you want to get the maximum value out of the GPU, the investment that you make, you have to make the memory more memory and faster, higher capability memory. So this is the heart of why memory and storage become the critical enabler for the revolution of AI. Now, how do you look at memory? And many of you probably know this kind of intuitively. So memory itself is tiered in any computer system, right? The slowest memory is the data lakes, the stuff that is like hard drives. Some of it is in tape drives also, and these are far from the processor, slow to access but very large, very cheap. And then as you go closer and closer to the processor, those are faster, much more lower density, extremely fast but expensive. So it's cheap to, so you can see the energy consumption is the opposite direction. These are non-volatile, obviously have very low energy, very high capacity, very low cost, and very, very slow latency wise. The other side memory is the fastest. But with the AI space, you have these spaces are getting more bifurcated now, because there are the traditional traditional way of looking at a hard drive and just SRAM is not going to work. So you can see the HBM has come into a big component. It's all off chip, and the on chip memory is the cache itself has been split into multiple levels of cache, and I have not shown here, but even on the solid state drive there are lots of bifurcations that are coming, that from the inference standpoint there are faster solid state drives, there are slower solid state drives. The faster ones can be a good complement to HBM. The GPU can effectively use HBM, as well as some of you may be reading about HBF, high bandwidth flash, which is like just change the name HBM to F, which is changing the DRAM to a flash chip. It has a certain, it won't have the same capability as HBM, but it can do some things which makes your overall cost cheaper, power reduction, etc. So this thing will split into multiple divisions as the AI infrastructure expands, as specific requirements step in. There will be a lot of specialized memories that you will see. If I show this chart, maybe in 4 years time you will have a lot more tiers in this, right? And as you can see, the growth of from where we started on this high-end smartphone to PC to the entire GPU generation from NVIDIA, from 2022 to 26, you can see the growth of RAM, right, which is what the HBM and the RAM is astronomical. But that's not, this is, everyone knows this, right? You can pull up this chart on the internet every day. But what's interesting to note is a GPU, NVIDIA GPU surrounded by 4 or 8 HBM stacks, but the amount of silicon area that those stacks have is 7x more than what the GPU. Now, that much of DRAM memory has to go to make that one GPU work. So the amount of that shows the criticality of the memory industry to make that one GPU work is 7 times more silicon that's needed, because that many stacked DRAM is sitting there. So I think this is the key for most of us to remember, that memory is no longer nice to have, but it's powering the revolution, right? And but then you cannot just go do that without taking account of the power, as we talked about earlier, the energy efficiency. We still have to have performance, as the GPU is still demanding performance, still have to have the capacity at the right performance, and there's no way you can make things more expensive, because the cost still matters to the consumer, whether it's the edge, or cost matters to data center, because we're all end consumers who want a phone with 256 gigabit last year. This year we want 512 gigabit at the same price, right? We are not willing to pay 2 times the price just because it's twice the density. We all drive that cost per bit reduction of 20-30% per year all the time. That's what drives the market. That's what drives innovation. I was told that the rate of innovation in this industry is faster than aerospace industry ever has done. Right? We all know aerospace industry is huge in innovation, and it's not to discredit aerospace, but the rate of innovation, how much you have to keep pace to keep yourself relevant in the market, consistently this industry has to be even more competitive and more challenging than even the aerospace industry. So that's the challenge in this industry. And this is obviously a competing problem, right? You have scaling requirements are getting tougher, and the cost is, so there are a lot of conflicting requirements that you have to meet to make the requirements of the previous slide happen. Now, inside so this is all talking about what we may have to make as chips to make AI work in the applications that we need. But inside a company, inside an enterprise like Micron or Intel or any of the companies that are work, or NVIDIA, you have to be able to use AI in various pieces of the ecosystem for you to get more and more efficient, because if your competition is going to get more efficient using AI, then they're going to get ahead of you. Right? AI will not replace a company, but a company that uses AI will replace another company that doesn't use AI. Right? I think that's the myth that many of us have to clearly realize, that even as an engineer working in a company, the fear is not about AI replacing my job. That should not be the fear, because we all have critical skills. It's an engineer with AI can replace an engineer who does not know how to use AI. That's the way to think about this. So we have to be able to use it in various ways in design to improve. If your design to tape out takes 12 months, can you do it in 8 months, 6 months, right? How do you make your efficiency? How do you accelerate wafer level learning, and how do you work on finding defects earlier? How do you simulate a product? We're talking about digital twins and many other ways. How can you simulate a defect before it even happens, right? Or how can you see a customer's problem even in a simulation way? So delivering for AI is one thing, and delivering with AI is another, and this has to be a cycle. We can't just make things for the industry. If you don't know how to use it within your own company, then we are not really getting ahead of the game. So you have to have both. Right? That's the mantra for us in Micron, and I'm sure many other companies. So where are the opportunities here? So as that first data showed, without data there's no AI. The whole idea, this is from our CEO, Chairman and President, who was at the opening last week of the Sanand facility in Gujarat. So without data there's no artificial intelligence, and you can see data generation in so many different places that's being generated, and so many different ways of processing it. And for specifically like in India, we have data in multiple languages too. So we have additional challenges, which means additional opportunity. Right? The companies that are developing LLMs, or sometimes called SLM these days, right? Small language model, mid language model, whatever name you want to call it, instead of trillion parameters, maybe billion parameters. Those things that are able to bridge the language divide across the country, or make it a strength rather than a liability for us, that's huge. That's probably a unique problem to India compared to other countries. So there's a lot of work in language translation. And we talked about in the video drug support, legal document. Nowadays a lawyer could throw a contract into a good AI engine, and it can summarize, and a lawyer would have to spend maybe 15 hours going through it, or have few assistants go over it. He can get the summary done. So he or she must be adept at using it, because another lawyer who is adept at doing it will get the case done in half the time than this person. So it is that pervasive and getting more and more accurate. Yes, we worry about hallucination and other things, but it is certainly getting very accurate. Right? Now, there's the industries that we really have to think about if we are thinking about making impact. In addition to workplace productivity, learning, there's Prakash and I were talking just before this. This democratizes learning, right? You can have a tutor that is essentially a customized teacher for each person, because each of us have a different way of learning. And learning in a classroom means you get information or teaching in one way, and everyone has to absorb. This essentially can be a bridge between the teacher. It doesn't replace the teacher, by the way. Teacher is still there, but it's an assistant that is customized to your specific way of learning. So your learning gets accelerated, maybe lifting all boats. Everyone can come up to a higher level of capability over time. So tremendous, and with the language divide in India, this is going to be huge. The learning is going to be a very, very big part. Detection and prediction, unfortunately, a lot of fraud is happening already, right? With all the amount of data that's sitting out there, you have to be very careful. But a lot of work in cybersecurity. Healthcare is going to be a huge one. I think we already saw a glimpse of it during the COVID, but that is very, very early stuff. But now I think there's phenomenal um, improvement. One of the areas which some of you already probably know is radiography, right? X-ray comes out, usually have a radiographer go through the X-ray, write a report, which is what we do. That works, but these engines are capable of finding things which even radiographer cannot see because they are subtle, because it's trained on thousands of images. Because the radiographer doesn't necessarily see it, but sees it, it looks for a pattern, sees it. Radiographer still signs off the report, so it doesn't replace the radiographer. Normally we would think that means I'll need less radiographers, correct? That's why we think we will lose jobs, 100 radiographers will become 20 radiographers. No, that doesn't happen, because there are more people waiting for X-rays in queue now will get serviced. So actually hospitals have actually reported that they end up hiring more radiographers because they can service more patients, because the radiography has gotten faster with this. So this is also another myth, that until you go through it, it's hard to believe that actually it is not necessarily killing jobs, but it's creating jobs in a different way. Maybe there's initial drop because there is an efficiency piece, but hospitals will be able to make more revenue, bring in more radiographers, because more patients will be serviced by the existing system. So there is that. So it's something like it disturbs, but it will settle back to a normal which is better than before. But you have to give it some time to settle, right? So the healthcare is huge, and there are many other drug discoveries. Lots of things are happening already. Smart manufacturing is very big, very important for most countries who are going to make in India or make in any country for that matter. How can you run a lights out factory, right? Essentially, not have people as much as possible run it on automation, but again, people are the nerve center to be able to program those things to run the right way. So it's not doesn't replace, but efficiency is better. Autonomous vehicles we talked about. So as I link back to the previous one, the memory and storage are the cognitive backbone for this AI, because you need the solid state devices to store these vast data sets from where you can learn. The HBM and the DRAM, which sits next to the processor, does all the thinking on the models. And then finally you have to act, which is the inference piece, right? It's still the memory and storage has to maintain the context, because I'm asking a question today, tomorrow I come back and ask a question, it has to maintain some level of context, right? So a lot of caches, you have probably heard of KV cache and all that, which is how it maintains these contexts. So memory and storage is critical for this entire ecosystem to run, whether it runs on the GPU in the data centers or on your phones. This is extremely important. Right? And I will come to this. The reason I'm talking about this is we all know about the performance and the capacity test. The power. We just having a conversation before this meeting. The power growth in any region in the world. The power growth. When I mean by power growth, is the power capacity that's being added is probably 3 to 5% growth per year, something like that. The data centers are asking for 20% growth of power. So it's an unsustainable equation. How can you add 20% power everywhere, right? Unless the companies themselves participate in building power plants and other things, or it will come with nuclear power, or you have to put the data center in water, or there are many ways, many innovations are happening, because the power growth is simply not keeping pace with the demands of the data center. So the power is, and if you go about it the wrong way, you make a very unsustainable solution, which is really bad for the earth, right? We can't create unsustainable future because of AI. So there's a lot of innovation in this piece. So that leads to this slide, that how do you, and this is a very big feature in Micron, and I'm sure many other companies too. is how do you use the data to enable sustainable manufacturing, right? How do you use data to minimize water usage, power usage, how do you recycle water, how do you use green power. So, and fabs are the biggest users of water and power, so they had to be at the forefront of driving the change because you're essentially consuming so much of the earth's resources. So the reason I put this slide here is, as much as AI growth is such a big deal, if we don't pay attention to the sustainability, I think we'll end up in a poorer situation than where we are today. So that's not something we all want to ever comprehend, right? Now, coming to India story on this is, this is a very, very, I would say, a watershed moment in the last few years for the growth of semiconductor as part of the India semiconductor mission and the government's push into this. As far as just talking about Micron itself, we are 4,500 employees in India, 30% new college grads, very high percentage in women, a lot of patents and industry awards. Our biggest facility is in Hyderabad. This is not a factory, more research, product development in all leading products, and the team has delivered a lot of new designs for some of our controllers as well as memory. So tremendous growth. We started, this is only about 5-6 years old, to grown to 4,500 employees, and last week we broke ground at the Sanand facility in Gujarat, as it's shown here, for the assembly test manufacturing. But beyond Micron, you can see the landscape of many of these of the companies are trying to establish a foothold. There are fabs coming up in Dholera in Gujarat, on the Tata fab that you're all probably aware of. So plenty of opportunities here from the fab layer of that AI cake I talked about, right? And when these companies come, obviously the ecosystem also brings a lot of jobs, right? If a company establishes a factory, let's say it's 5,000 jobs, the ecosystem of suppliers who come will be another multiplier of another 15,000-20,000 jobs in that area, because there is equipment suppliers, there is power, so many other infrastructure will also boost the economy in that area. So these are very, very critical for job growth of the number of graduates that are coming out of the Indian universities. Right. Now come back to the AI cake again. Now this time the emphasis is not on the left, but the emphasis on the right, because as you know, in IIT or any of the premier institutions, we have so many people pursuing the degrees in multiple disciplines, and everyone is wondering, if I don't know LLM, how can I survive? That's not true, right? If you look at energy and power, we have EE disciplines, mechanical engineering, civil, multiple other disciplines. You look at maybe chemical engineering too. Chips and computing, of course. We always think chips and computing has to be electrical engineering. I've realized over the last 30 years that material science is key to it. So material science engineers have made extremely good careers in physics. People have made good careers. It's not that everyone in the semiconductor industry employs is electrical engineers. If that is a myth, you can consider that as broken today, right? Sorry, that's me. So it employs people across multiple disciplines. The cloud infrastructure, definitely you need computing, electrical engineers. Model building, probably more computer science, but again EE too. An application layer, you need smart people, that's all. It doesn't mean any discipline. Smart people can come from many disciplines who can make a difference to the utilization of these models and applications. So I think the message I want to leave, because this being a larger student pool, is there is opportunity in every discipline, and I may not have called out all disciplines here, that this revolution, once in a lifetime infrastructure change, has roles for everyone, and you don't have to think that I have to be a computer science engineer to get benefit from this change, right? You can make a difference to this industry. You can make a difference for your own lives, being in anything, as long as you are focused on the areas that are driving the revolution. Right? Now, I expect a question at the end of this slide. I kind of left it mysterious. This is probably easy to read. I'll read this out. but I will wait for somebody to ask the question and I will explain. So AI is coming at us really, and I want to end this by 6:15, so I will leave time for questions. Is really coming at us 10x faster and 10x bigger, right? It's not something we are going to be. It's a bullet train. We cannot stop this, right? It is in for companies, and most of us, or not just companies, any of us students here. It's not optional, but it's a core capability. It's a business imperative for all of us to be able to latch onto this. So it's not like I can stand on the sidelines and let this train pass by. Not possible, right? But it's a generational change in infrastructure build out, those 5 layers. So, and those of you who are coming into the workforce in the next several years, you are going to be part of the revolution. So you can make a huge difference to yourself and the industry. It is going to be there's going to be societal changes, business transformations. As we are talking, existing businesses have to make changes to adopt the AI, to adopt and make use of the AI models. It will be a national security challenge. That's why all countries are going to invest in it individually. Every country is trying to secure it, and each country has unique challenges. Like we talked about language challenge for India. So you have to have this infrastructure work around your unique problems. There are global problems you can use OpenAI model, but there are local problems that you need to build your own models. That's why the push to drive models, and I think there were some fantastic companies that were showcased at the OpenAI summit, Sarvam AI and multiple. I mean, they're phenomenal. I went through their interviews, and they're really localized to context. They're not trying to compete with OpenAI, but they're doing work that is absolutely critical for India. And I want to leave this point. Become AI natives in your own field of study. And this is something I always say to every student batch I meet. Whether it's you're an electrical, chemical engineer, physics, material science, focus on the core competency. Then make AI as a tool for you. You become AI native, but you don't lose your field of study. There's a myth when I talk to many of my friends and their children. Everyone says, "Oh, just go study AI." You have to grab your core competence, which whatever that may be, and AI is a tool that you use to enhance your learning in that area. There is no, you can't, like I said, there is only small number of people who are going to build models. So this learning AI should be a tool. Just think of it, at some point AI will become like an Excel. You don't go take a degree in Excel file, right, or PowerPoint, because it's a tool for you to get your job done faster, because your interest may be in electrical engineering, mathematics, can be physics, it doesn't matter. The Excel is an aid. So AI is also an aid. Think of that way, and don't lose your core competency, and everyone end up thinking that they want to do computer science for the sake of building models, right? That field will be crowded out. And don't fear it, no, embrace it, because it's a cognitive multiplier. If you use it as a co-pilot, I like to use this example. Use it as a co-pilot, not an autopilot. It is not autopiloting for you. It is co-pilot. You are still in control. If you use it that way, it's only an asset for you, right? Today, can you imagine doing calculations with an Excel file? You cannot. Right? It has come to that point. It's the same thing. One day you will find that it becomes your own cognitive multiplier. It gives you ideas, refines your own ideas, but you are still the controller of the ideas. It's not controlling you, right? But the key is you need to start to be great. And I say this to a lot of engineers who join my team. You don't have to be great to start. You don't have to be AI wizard to start working on it. But you have to start if you want to become good at it. If you don't start and stay on the sidelines and just read about it, read about Anthropic, there's no use. You have to start using it, refine it, it learns from you, you learn from it. So you have to get used to it, right? And that's why I said you need to start to become great. And opportunities abound in all the layers of the cake, right? So you have plenty to pick from. You don't have to be thinking of only one narrow discipline. So there's plenty of opportunity. I'm waiting for the question. Why is the Nataraja there? Okay. Since I have 15 minutes, maybe we should ask the audience. Any guesses on why the Nataraja? Hey, I put the Nataraja figure today, by the way. I was thinking about what to put, but I want to put something that excites, creates some curiosity. And I will explain if some of you may know this answer already. Why is Nataraja there? Okay, I'll give you a clue maybe. what does this imply? This hand. Fire, right? And fire does what? Burns, destruction, right? And the other hand is the Damaru, right? This is the creation. So essentially, this is a symbol of creative destruction, right? The AI, essentially, you should think of it as a creative destruction. Means whatever we were doing earlier, we have to make changes to it and embrace this. It's a creative destruction cycle. Ultimately, it will come to a point where we will be better off than where we were. But there is a time of uncertainty where there is some destruction happening, but it is creative destruction. Total destruction means X number of jobs became much less. Creative destruction means started here, maybe there is a pause, but finally you come back to a better point than where you started. So Nataraja is a clear example of creative destruction. Right? You don't want to be this ignorant person not wanting to know what's going on. That's what she was pressing down on. Apasmara Purusha says, right, that you don't want to be this ignorant person, that he's suppressing ignorance. So you want to be absolutely aware of this revolution that's going to happen, and there is plenty of opportunity, plenty of creative destruction, so don't fear it. So that is my message. I wanted to close on this talk and open for questions. Thank you.
So one of the biggest bottlenecks right now has been data movements, right?
Yes.
So where do you see some architectures like in-memory computing going for?
Yeah.
Like in the longer term.
Good question. Very good. Excellent question. I did want to talk about it, but I didn't have a slide. That's a extremely good question. The power space, since we are talking about low power and being power intelligent or power sensitive, lots of power is burnt when data keeps going back from memory to GPU and back. It's just burning data. So what if you could do some of the processing in the memory itself, right? Memory itself is still a matrix. Can you do some of the memory? And that's why there's what's called a PIM, processing in memory, and there's also called PNM, processing near memory. These are all architectures to reduce power usage. It is not as simple in the architectural. You can do that today, but the system has to adopt. The entire processing system has to be able to adopt that kind of a system where it looks as the memory as a processing vehicle also. So I think the system changes have to be driven to make that happen. So it's not the processing itself cannot be done, but system changes are not there yet to absorb it. So I think every company is looking at some of that processing in memory, processing near memory also. That's a good question. A very good question. Yeah.
You said that you will talk about AI bubble. So
Oh, you really listened to what I said in the beginning. Very good. Yes.
I think that AI bubble is real. It might not be immediate, but it will happen. It's like Moore's law. We say that the size of the chip cannot become smaller and smaller. We do have constraints. We try to compensate it by having multiple chips on the same computer. Similarly, we cannot keep on giving data more and more to the same AI model.
Right.
So I do think that
there is a bubble.
Yeah.
Okay. How many of you think there is a bubble? How many of you, show of hands, how many of you think there's an AI bubble? Only 2 of you think AI bubble. Rest of you think it's not. Okay. Maybe more people. It's very hard to predict markets, AI bubble, and when things are going up, nobody is going to agree it's a bubble, and things are going down, everyone says it's broken. So to me, it's not that clear. The only thing I would say is, and I can only compare to the past. So the previous time we had anything close to a bubble is during the internet revolution, somewhat during the mobile phone revolution, but more on the internet revolution, where there was this massive overinvestment in the internet, and there was a bubble, right? The difference between that and this time is, as much as the investment is going to the models and data centers, the utilization point of this is typically, let's say, all our devices, be it phones or or PCs, those are already there. That means you can push models to the consumer today. So the utilization point is already available. The difference in the internet was the infrastructure was not there. The investment was far ahead of the infrastructure. Infrastructure took long time to build out. So the bubble really burst. In this case, the bubble may still be there, maybe longer term, but for the short term, the value of creation of this is still, there is an ROI because the devices that are utilizing are already there. So it plays out probably differently from the internet, but maybe in the end of the road it can still be a bubble. I don't know. I'm not sure. That's the only difference I can see.
Hello, sir. It was a great talk. So, my question is, you were saying that we still need to increase in the improve in the memory technology, but then in terms of fabrication, there are a lot of difficulties in scaling down the memory.
Yes.
So, what immediate plans is Micron thinking of to scale down the memory?
Oh, scaling challenges have been there since I started working in the industry, right? When you're working in 30 nanometers, you think you cannot go to 25 nanometers. You go to 25, you think you cannot go to 20. So when I said not possible, I didn't say it's not possible. I just said these are challenges and there are multiple competing priorities. There was a time where the industry was driving just cost, let us say. The performance and the power was not as much of a big deal as this because of the AI revolution. So let's say you're driving one vector. Now you have to drive multiple conflicting vectors and still get to the end state, which means you have to make intelligent choices of architecture changes, etc. But no, I think there is plenty of innovation that will drive memory and storage industry for the next several years to come. I don't think we're anywhere near the end of scaling, if that is your question. That's because in NAND, if you think about it, scaling is vertical, right? Because we have gone to the point where the two-dimensional charge storage is not sufficient, so we have gone vertical. DRAM is also thinking of going vertical, right? You can see papers on vertical 3D DRAM. So everyone's trying to utilize not just the XY space, but the Z space also. So there's plenty of innovation that will take care of the industry for the several years to come.
So, what are your point of views on the non-volatile memories, like emerging non-volatile memories like RRAMs, PCMs, and all those things?
So those have always been at the sidelines for several years, right? As you know, a lot of a lot of academic research goes on resistive RAMs and other RAMs. As long as the industry is still getting value out of DRAM and NAND, and scaling has not stopped, it's very difficult for them to penetrate main memory. But as I said, if this architecture starts bifurcating into multiple architectures, because of that, it's not so simple drives and storage and DRAM and SRAM, then as that bifurcates, there will be space for many of these applications. They are not, so the myth, the paradigm we have to get over is, for a long time in the industry we were thinking, are they going to replace DRAM or a NAND? I think the paradigm is not going to happen. It is going to be coexistence, and that means you have to find unique applications where maybe you are willing to pay a little bit more, but you want high level performance. That finds a niche market, but that market can be big. If this AI space is so big, it can still be a growth engine for those memories, but it's not replacement, it's coexistence.
Thank you, sir.
Since LLMs are for any of the big models today, memory is the main bottleneck.
Yes.
So there is this thing whether sort of all the industry efforts and innovation will go towards making models work on the edge on people's phone.
Yeah.
Or since network connectivity is also improving in parallel, they will bias towards running it in data centers where the type of memory itself is different, where you're bandwidth oriented and so on, and then just have the user be a thin client of that, right? So here also, do you see, just like you mentioned now with resistive memory, this coexistence with different applications of both approaches?
Right.
Or do you see it going biased entirely towards one approach, that is either data center and then streamed, or more of an edge approach?
It will still be coexistence for the simple reason, one, as a user you want latency, right? Yeah. You cannot afford to wait for something to go to data center and come back, because we want a click of something, it should come up. So there is latency, and then there is contextualization for you as a user. You want security for the data, how you communicate. You want that to be secure. You don't want data center to know what you're doing with your phone. So both from a security as well as latency perspective, the edge has to coexist with the data center. I don't think, and so you can have two sets of models essentially, for one for the data center for the large data and one for SLMs for your phones.
Because for a lot of things today, nothing even before without AI, people have already made the trade-off where they are okay with having more or less cloud connected application, and they are in most cases people simply deal with the latency and the privacy costs.
Correct.
So I was wondering if a similar thing you see happening even for LLM.
No, I think devices have to get better. The models on the device has to get better. When Google releases a Gemini on the data center, they also have a Gemini version for the edge devices, right? So it has to get better on the devices, right? Anyone else? No, I don't think so. Maybe if you want to answer the question in a classical way, maybe yes. If Moore's law is about just packing transistors from a X dimension, yeah, okay, you can say it reaches a point where it reaches atomic dimensions where you cannot really store information or data. But that's why we are all going 3D, gate all around, and 3D transistors and all that. So you're just getting around that in a more intelligent way. So I think human innovation, you know this very well, right? Many papers are written in the last 20-30 years. Every time lithography hits a wall, say, oh, that's it, 7 more years, lithography is out. We're still doing lithography, right? From 1990, I've read papers that said, oh, next 7 years lithography will run out of steam. No, we ran 365 to 248 to 193, 193 immersion. Where does innovation stop? So human creativity cannot be put in a chart and say it will stop here, right? That's why humans still exist with all the AI systems. Right? I think it's not called Moore's law. I think there's a new name for the 3D, the three-dimensional thing. I forget the name. There's somebody came up with some new law. I don't know what it's called, but I'll find out. Yes. Products are non-volatile, like not NAND, you're talking about which? Like resistive RAM, PCM resistive RAM.
Why are we not seeing any products? Is it because of incompatibility of the existing fab facilities, or are these technologies are yet to get matured?
Yeah, no, it's not incompatibility of the facility. That's not the reason. Many of the companies have had very big programs on these alternate memories. We can make it work, but like I said, it's a trade-off, right? Either the cost is high and the ROI is low that it doesn't make sense to intercept any of these spaces, or the ROI is looks high, the cost is extremely high also. So it does not find an economic viable point, and the scaling of the conventional DRAM NAND continues to keep going. I'll give you a parallel answer to this. The parallel answer is, why is hard drive industry still surviving? Right? Solid state drive, if you are a user who buys a notebook with a solid state drive, you will never buy a notebook with a hard drive, because mechanically it can fail anytime. Right? A solid state drive, you know that. If that's the case, hard drives should have been completely wiped out. Hard drives are not wiped out because the cost point of hard drive is still lower than solid state. Yeah. There are applications where you're not shaking the data center or something. There is long-term storage that people still find value for cold data. It's still stored. So it is not replacing that space. Right? It again is a coexistence. So as data migrates, as data splits into hot data and cold data, all the hot data ends up in the solid state. The cold data still in the tape or solid state. It's similar. So otherwise you should have replaced it, right?
But we couldn't see any minimal number of products at least.
Oh, there are. I mean, if you look at some products on PCM, yeah, there are products. Very small.
Intel Optane.
Very small product.
Very small. That's
very
what making it so small.
The other thing is systems have to adopt, right? If the way you access a PCM, your read writes are different. So the algorithms, how a processor has to address that, versus how it addresses. All the systems are built around classic RAM and solid state, right? Your controllers, your data pipes.
Yeah, yeah.
Now to do this, I have to change. I will only change if there's an incentive for me to change. The incentive, we haven't tipped that scale to make it incentivized. So where it's a very niche application, okay, people will do what it takes because it's so niche, they will do what it takes. But if it's a general application, it has not
So
found
is it not worthy to continue research?
No, like I said, I think niche application still has value, number one. Number two, when you bifurcation of memory happens, there will be more niche application.
Yeah.
Number three, this is my scientific side of me says, work on any of these, even if that memory doesn't materialize, what you learned it is always scientifically useful to do something else, right? We do many projects in any companies where something doesn't succeed, right? When you join an R&D team, if you do 15 things, maybe 5 of them don't succeed, but doesn't mean those 5 are failures.
Yeah.
You learn something that makes the other 10 much better. So I think none of this is scientific work cannot be always based on outcome, right? It is based on you
What
do
you
it
have
because it's the right thing to do, and then you learn.
Thank you, sir.
Okay, I think you're tired after 1 hour, probably. All right, thanks. Thank you very much.
All right then. Thank you everyone. Definitely navigating this AI era isn't just a talk. It's a blueprint for innovation as well. So thank you everyone for coming over here. A big thanks to sir for taking out the time. That's a wrap on today's leadership lecture series. Thank you everyone for coming over here.